Here is a mathematical example of an explosion problem using conservation of momentum. The problem reads, think back to the lab. Two carts are initially sitting on a table. Cart A has a mass of 1.46 kilograms. Mass of A equals 1.46 kilograms. Cart B has a mass of 1.34 kilograms. An explosion suddenly happens between them. This causes cart A to move with a speed of 2.8 meters per second. We need to find what is the velocity of cart B. The last part of this, cart A begins to move at a speed of 2.8 meters per second, tells us that the velocity final of cart A ends up being 2.8 meters per second. Initially, the two carts are sitting on a table. Therefore, the initial velocity of cart A and the initial velocity of cart B are both going to equal 0. In the last video, we talked about the fact that momentum is conserved, given both bodies in the system. Therefore, we can write out the following. The momentum of A initially plus the momentum of B initially equals the momentum of A final plus the momentum of B final. So let's plug in what we know. Cart A has a mass of 1.46 kilograms, an initial velocity of 0 meters per second, plus cart B, which has a mass of 1.34 kilograms, and an initial velocity also of 0. That has to equal the final momentum of cart A, which has a mass of 1.46 kilograms, a final velocity of 2.8 meters per second, plus the momentum of B, which has the mass of 1.34 kilograms, and an unknown final velocity. When we go through and calculate, we find out that initially we had 0 momentum plus 0 equals 4.088 kilogram meters per second plus our 1.34 kilograms times VF. So we'll subtract our 4.8 over. That would equal our 1.34 kilograms times our final velocity. And what we end up seeing is that our final velocity ends up equaling a negative 3.05 meters per second. In the lab, hopefully remember that we wanted to find carts that both ended up having the same momentum. That's because of this step right here. The fact that the momentum of cart A finally had to equal the momentum of cart B finally. The reasons their velocities are different, we had 2.8 for cart A and 3.05 for cart B, is simply because they had different masses. The reason why our final velocity for cart B is negative is because it moves in the opposite direction. If I lost you on any part of the problem, go back, play until you understand, hit pause, and then continue once you have your work written.